All right, I'm not collecting today's warm-up. You can write it on your notes. Right, warm up. Today is second.
Sorry. Nope.
February 6th. Okay. So just a little short question here, which is what is different between the output values of the function f of x equals the square root of x and the function g of x being the square root of x plus 2. What are some differences that you can say? I'm gonna go around, give you guys last week's warm up. Kenny. Logan. Esther. Sarah. Eric. Gomez. And just jot down some, any ideas that you have. No, wasn't really. Victor. Okay, let's see. So I think the usual U4. We need to do a little bit separate paper here.
Which one?
U4.
So we're not printing it in,
Okay.
so it's part of our notes.
U4 here, and then the same 4 in the front. I think that's pretty much the same, yeah. U4 here, check it in. You say it here, check in. And then you guys. Okay, so do a quick check-in, just see what your classmates said. What's some differences between the output values of F and G?
Sad.
You all want to pick that, right? Right. But it's all like this. It's like the only difference from just like it's not. I can check that with these on here. So, two different places as well.
Okay, let's see. Let me hear from someone in these two rows. Anything that you guys said? Anybody? B.
For the output values, because g of x has a +2, which means the value for g of x will always be 2 more than f of x.
Okay, so you're saying output values will always be 2 more than f of x, the output values here. Okay, cool. So what do you think would happen with the graph of this one versus the graph of this one if we go off what B said here?
It would go like 2 places higher. It
It's
would-
gonna be positioned 2 places higher compared to the graph of this. Because the Y values are gonna be 2 units higher. Cool? Okay, so that's gonna be the theme of today. Called function transformations, which is about, I have a function, but if I tweak something to it. How does its graph get tweaked out? The output values, yes.
Would we need to specify that it's the Y, that will be 2 more?
That will definitely help, yeah, so the output values will always be 2 more units, so you can say the output Y values. Well, that'll be important too, yeah, because you're gonna wanna distinguish today. Did I change, what's the relationship between the graphs? Is it the X coordinates that are changing or the Y coordinates that are changing? That will definitely be important. A good addition there. Okay. Then my marker. So keep your warm up, I'm not collecting it. And so we're gonna jump back a little bit to section 3.4 called function transformations. Does everybody have a packet that I passed out? Okay, so if you just turn to the very back of the packet. This whole entire class is gonna focus on these functions. Okay? Called we're gonna call them parent functions, they're like the core functions. So I can't change, no, how do I say it? I can't get from one function to another function by just adding or multiplying it or dividing it by numbers. There's no way for me to go from one to the other if I just add, multiply, subtract, or divide it by numbers. Versus like here, we just added by 2 to change it, right? So the reason these are called parent functions is each one has its own essence in terms of how the Y values are changing. And so for today, I'm gonna have you guys reference these parent functions. Notice that they tell you the domain and the range. They give you the name. So if I say linear, quadratic, cubic, what I want you guys to practice this semester, so that when you get to the final, is if I see a function that looks like x cubed, I have a general idea that the shape will look like some curvy S. Okay? Versus if I have the square root of x somewhere, if I just see the square root of something, the overall graph should have a general shape that looks like the square root function. I just manipulated it and transformed it. Yeah.
Will
question.
we ever see those bottom 2? Because I've never seen them before.
You will definitely see the constant function. So that will be like y equals 5. It'll just be a straight line where all the y values are 5. You might not see the greatest integer one. Sometimes that one's also called the step function because it looks like stairs. But you'll see things that look kind of similar to it. And I think in calc, you'll definitely see more complicated versions of that. But the other ones you will definitely see. Yeah. Okay. So you guys are going to go off of this today. And what we're going to do is we're going to change these parent functions to get what's called a function transformation. So we're going to start first with something called a vertical shift transformation. That's you. A vertical shift transformation. And so it's going to go off of what we did in the warm-up. So we have our square root function. And then we have g of x, which looks like the square root function, but we added 2 to it. Let's do a little bit of some table values just to play with some data. And look at the x and y coordinates. Okay. And so let's just play with it real quick. So if I look at my handout, what's my domain for this function? You look at the back of the handout. Find the square root function.
0 to infinity.
0 to infinity, because we can't plug in negatives, right? So you can plug in 0 or anything greater. So let's start with 0. So if I plug in 0, plug it in, what's the square root of 0?
0.
0, so you get 0. Plug in 1. Square root of 1?
1.
1. And then let's plug in a perfect square to make the numbers a little easier. 4 is the next perfect square. Square root of 4 is going to give you 2. Okay. So let's just do a quick sketch of the graph. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to plot these points. So we got the point 0, 0, 0, 0, 1, 1, and then 1, 2, 3, 4, 2, 3, 4, 4, 2, which is right here. And then notice that it agrees with the overall shape that you guys see in your handout. It goes like that, right? And it'll kind of keep increasing, but slowly. Okay, so that's the overall shape of the square root function. And so now let's just test what we were discussing here. We were saying that it should be kind of similar, but the output values will always be 2 units greater. So let's plug in the exact same x values. So we get square root of 0, we plug it in, and that's square root of 0 plus 2, which is 2. Square root of 1 plus 2, it's a big fat 3, and then the square root of 4 plus 2 is 2 plus 2, 4. So yes, it's true, these y values are 2 units greater than these y values of the parent function. So let's plot that. Let's see. We got 0, 2. We got 1, 3. And then we got 4, 4. So notice also what you guys were saying is true, is that this is 2 units. It went up 2 units. Okay? And so let me show you on Desmos how you can use this to help you with the homework. Bring this down. Wait, you can still see the table there. Okay. Let's see. I'm going to move this up.
Is this a scientific calculator or do I need to?
That one's good. That's a scientific calculator. Yeah. Okay. So let's go to graphing calculator on Desmos. I'll bring this down. Okay. So I have f of x equals the square root of x and g of x, which was the same thing, square root of x plus 2. So that matches what we have there. Now Desmos has this thing called the slider feature. Okay. So instead of putting a number, I put a letter. So like, let's say I put the letter C. And it'll detect, and it'll say add a slider. So then I click add a slider. And right now what it's doing is that it's plugging in the value of C equals 1 here into this function. So how many units higher is the function G? Right now it's only 1. Because right now, think of this as reading it as square root of x plus 1. Versus if I move it to 2, you see how the graph went up 2 units? So if I move it up to 3, it'll go up. Now it's 3 units above. And so notice that as you keep increasing this value, the y values also keep increasing by that same amount. Okay. Now, what happens if I make it negative? Like, let's say I move it down to -2. What do you think the blue graph will be doing? Let's take a look. And that's the fun part about the slider. You kind of animate the graph. Notice that when it's 0, it's exactly on top of it because it's the same thing. But if I move it down now, if I'm subtracting by 2, now the y values are 2 units less than the y values of f. And so then the same thing. So then the graph will go down. Cool? Yeah. Okay. So let's go back. Show you that, how you can use Desmos for that. Okay. Now a little bit of the algebra that comes into play here. So let's make some remarks. So the first one is notation. So notice that we're saying the parent function right now is the square root function. That's the one we're using. And so this little arrow here in math, it usually means implies. Okay. Implies. Or you can read it as like then. So since blah, 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 then or implies that because I'm rewriting the square root function like this, what we can do is, here's where the algebra comes in. What else are we calling the square root of x? Just this part. What's another way to rewrite this here? We're saying the square root of x is equal to f of x. So what this section is going to do on your textbook is they're going to rewrite this. Instead of writing it with the square root, they're going to write it like this. Okay.
Could be like log or something.
Kind of. It's kind of similar to that, but it's not a function. Kind of. It is kind of like a function going inside the other one. It is kind of like that, yeah. But that might make you a little bit more uncomfortable. Okay. But if you look at what this is saying, it's kind of literal the math translation of what we wrote here. We were saying that G has the output values will always be 2 more than f of x. And that's exactly what this is saying. G of x is always 2 units greater than f of x, which are the output values of x. Okay, so your textbook is going to write it in this notation. Okay. Now, if you guys look at your handout, you go back to the front. On the very top, you have vertical shift up and a vertical shift down. And so, like I was showing you guys on Desmos, it depends. If I'm adding a positive to f of x, then that'll force the parent function to go up that number of units. But if I'm subtracting it, it forces it to go down that number of units. Okay. So let me give you guys an example. You guys can see more like what the homework's going to look like. It's going to say, given the graph of f, graph its transformation y equals f of x plus 1. Sometimes they'll give you the algebraic expression of the parent function, like in this example, or they're just going to give you the graph, which is what I'm going to do right now. So let's write up to 1, 2, 3, 4. Bless you. 1, 2, 3, 4. So they're going to show you just the graph of it. They're not going to give you the actual algebraic expression. So let's connect. Let's have these points connect from here to 0, -1. That'll connect like that. And then draw a point at 1, 2. And then connect it with this bad boy. And then 3, 1. Connect it over here. And it'll say, this is a graph of f. What the heck is the algebraic expression? I have no idea what it is, but this is the parent function f. This is the original graph. What we need to do is now graph this transformation, f of x plus 1. So draw these points on your notes there. -0, -1, 0, 0, -1, 1, 2, 3, 1. And so something I'm going to have you guys do a lot today is first try to understand what transformation is happening. Okay, but plot this real quick. Plot the graph. I'll give you guys some time. Warm in here today. Question, yeah.
How would we signify, because that's, would we call the other graphs in there, the other graphs something else, the other function?
I guess we can write it, let's call it geodex.
Alright.
Let's call this geodex, so we can, yeah, you're right, we can label it. Okay, so what is this transformation going to do to this parent function graph? Shifts it up one. So we're gonna say that in different ways. We can say shifts up 1 unit. Or you can say, how is it affecting, you can talk about how it's affecting the graph, or you can talk about how it's affecting the coordinates of the graph.
Why would it always be one?
Yeah, so is this going to affect the x coordinates at all?
No.
No, right? When we did it on Desmos, the graph never went sideways. It only went up and down. So it only affects the y values. What are we going to do to the y values? We're going to add 1 to the original y values. For all these y values that are in the original graph, you add 1 unit up, which is another way of saying it shifts up. So this y value, what's the y value there? 0. So I add 1 to it. What's the y value here? -1. So it moves up to 0. The y value here is, so it goes up to 3, and this one's from 1, goes up to 2, and notice that, yes, it does indeed shift up the graph 1 unit up. Yeah, I'll just leave it like that. And so then now we can label this as G. I think that's what you're asking. So, like I was saying, either they'll give you the algebraic function first, and you guys are going to use your handouts to figure out what the graph looks like, or they give you the graph of f, and then you move it according to the transformation. Okay. I'm going to leave these two here, and I'm going to have you guys try one out. Do a quick check. Okay. And then we'll go around, check your guys' work, answer questions. So graph the parent function f of x equals the absolute value of x. And then graph the transformation g of x equals the absolute value of x minus 3. First, graph the absolute value function. Now remember, you got to be careful with putting at the end of the graph, putting a closed dot or putting an open arrow, because now that affects the domain and stuff, right? So for your absolute value function, does it stop or does it keep going? Alexa? Is Alexa here? Bobby. Aurora? Release. Oh, like that, no. All right, guys, just check real quick with your classmates. See if you guys are getting the same shift. Same shift. Careful how it's looking.
No, like, I meant like, because I'm guessing myself.
That's what I.
So,
We're just playing with
Should go up. Like one X, one Y on the right side and the same on the left side.
Don't be afraid to ask questions. The wings are gonna get spicy really fast today.
Actually, on the left side, it's Y is going negative. But that's you.
Yeah. I get it.
You know,
I think so. With the minus? Yeah, you're.
It's very funny.
There. But that's good, but it really.
Okay, good.
Would have to be. Another 2 boards.
1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so hopefully you guys are getting, don't forget, some people were graphing just a line. That would be y equals x, but the parent function has absolute. So then therefore the graph will have to look something like this. Looks like a V. Right, absolute value of 1 is 1, absolute value of -1 is also 1. And what does this bad boy do? Shifts it down 3 units. What does it do to the coordinates?
Bring them down.
Which one? The y coordinate gets subtracted 3 units down, right? So then it'll force it to go, all these y coordinates move down 1, 2, 3. 1, 2, 3. 1, 2, 3. So then you're gonna get your absolute value function moving down. Here's F, here's G. Cool? Okay, and the concept's the same. If you add or subtract, you move it up and down. All right, that wasn't too crazy. Let's go to the next one. Been good. Okay, so the next one, what do you think we're gonna be shifting? So if you don't shift up and down, you're gonna shift
That's right.
sideways. There's many dances, right? With that concept. Side to side. All right, so these ones, we're gonna call them horizontal shifts. And again, we're gonna play with the square root function. And now let's look at f of x as the square root function. But now, let's say g of x looks like this. Instead of adding the 2 outside of the square root, we're gonna add the 2 inside of the square root. Okay? Let's see, I'm gonna make a little table again. X, Y. And again, same points, 0, 0, 1, 1, 4, 2. Same as last time. But now I want you guys to see how it's going to affect, if it's moving sideways, which coordinates will it affect? It's going to affect the X coordinates. So now I'm not going to move the graph up and down, only sideways. So the graph is not going to move up and down, the Y values will be the same. So now the Y values are going to be the same. So what I want you guys to quickly figure out is, if I want the Y values to stay the same, what X values do I have to plug in here to give me these exact same Y values? Okay. Then when you guys do that, I'll just put this right here and get it ready. 1, 2, 3, 4. Do a quick check with your classmates here, see that you agreed. So you're answering right now, what X value do I plug in here so that the final result gives me 0? What do I plug in here so that the final result will be 1? That's what you're trying to do.
It's a little bit of a backward.
So the second one. The other one plus one would be one.
Okay, let's see. What are you guys getting for this guy? -2. Again, let me just, in case you were like, how the hell did you get that? You're trying to figure out what you can plug in here so that it gives you 0. Okay. The only way this can be 0 is if you square root the 0, right? But if I want to square root the 0, I want the thing inside of this to be 0. So what do I have to plug in here so that the inside becomes 0? -2. Because it'll cancel out. Okay. For the next one, you want it to equal 1. Therefore, what do you have to square root so that you get 1? What is it?
-1 plus 2.
This square root of this gives you that? You want the inside to be a positive 1, right?
Yeah.
So therefore, what do you have to add the 2 to get a positive 1? Negative. Right, -1 plus 2 is a positive 1, then I square root that, and that'll give me 1. Now for the third one, I want this to equal to 2, so what must I square root? I need to square root which number? 4. I need a square root of 4 to get a 2. So it's like backwards, like we're starting from the final result and working our way up. So I need a square root of 4 to get a 2, but therefore I need to add what number? 2. So I get 2 plus 2 equals 4, and then I square root. Yeah, yeah. Okay, so now let's say I look at the warm-up, kind of like the warm-up question. What's the relationship between the values of the parent function and the values of this transformation? Yeah, let's plot it. Let's see. So it looks like you're saying left. So the parent function is still the same one. It's still 0, 0, 1, 1, and 4, 2. So this is still F. Now, when I plot these points, this one's at -2, 0, -1, 1, and then 2, 2. So now notice the graph shifted to the left, right? It shifted 2 units to the left. So it went 2 units. Okay? Which is counterintuitive because I see in my brain, I see a +2. So that makes me think I should increase by 2. But we're noticing that that wasn't true. In this case, it actually went to the left. It went backwards. And so again, let me go to Desmos. Okay. Go to Desmos. Here's the square root function. So now instead of adding the c outside of it, I'm going to add the c inside of the square root. And you move it to 0. Okay. So if I add 1 unit inside the square root, look what happens. The graph shifts 1 unit to the left. If I add 2, it shifts 2 units to the right. I'm sorry, to the left. And if I keep adding a bigger number, it keeps moving it to the left by that number. Versus if I subtract by 1, it actually moves it to the right by 1 unit. If I subtract by 2, it's moving it 2 units to the right. So it's doing the opposite. And that's going to be something that might throw you off a little bit, okay? Because the problems are going to get more complicated. Yeah. Go ahead.
Isn't there a formula for both sides?
We're getting there. Yeah, we're getting there. So you guys look at your packet. We did actually, hold on, let me stop this here. If you guys look at your packet, we did the 3 vertical shift up and down, and then the next one is horizontal shifts left and right. But notice that it says the opposite. So if I'm subtracting inside by a number, it actually moves it to the right. And if I add by a number, it moves it to the left. Okay. And then on the very far right column, that's showing you how it affects the coordinates, which is something we're going to do once the problems get nastier. And so again, just focus on the notation. Where's my tablet here? No, focus on the notation. We have f of x equals the square root function. So therefore, or that implies that if you guys think of what we were doing last week, composition, right? And I asked you guys to decompose this into 2 functions, just the way I had you practice it. X plus 2 is inside the square root function. So notice that you're plugging in x plus 2 into the parent function square root of x. So this transformation that we did here is written this way in function transformation notation, which matches what's on that handout. It's f of x plus 2, but it really shifts the graph 2 units to the left. Cool? Okay. All right, so let's do an example. It's a little bit, now we're going to combine it with both of the things we just learned. Okay, so given the graph of f, graph V transformation g of x equals f of x minus 3 minus 1. So now I'm kind of combining the notation that we just learned. One, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 1, 2, 1, 2. Okay, now the parent function is going to look very different. So let's make it so that the parent function starts kind of like as an upside down parameter, passing through these 3 points. So let's make this the parent function x. That's how we start. Anybody watch The Last of Us last night? I was disappointed. It's just too short. I wanted more. Okay, so if you guys look at your handout, what you're gonna want to do first before you start moving is identifying what's happening, what transformations are being applied. So this part here, what's it doing to this parent function? Horizontal, which direction? Opposite, right? So it's gonna move to the right. So we can say right 3 units. Which coordinate does it affect? X coordinate, right? So I'm also gonna write that. Add 3 to X. I do the opposite. I see minus, but I really add 3 to X. Then I have my -1 outside of the parentheses of F. So that's going to be what type of transformation? Vertical. Notice that for vertical, the plus C and the minus C is outside of the parentheses. So that's going to be a vertical shift. How is it moving though? It does, if I see a minus, it actually does go minus, right? It does go down. So this goes down 1 unit. Which coordinate does it affect? Y. So what we're going to do is we're going to subtract 1 to Y. I'm going to show you how to do this in 2 ways. If you're a very visual person, you can get the graph. And because both of these are doing the operations of addition and subtraction, it doesn't matter which one you do first. Okay. Later on, we're going to multiply and divide and stuff. So then the order will matter. So it doesn't matter if I move 3 units to the right and then 1 down, or if I move down and then 3 units to the right. The order doesn't matter. You'll get the same result. So if you're a visual person, you can just visually move it 3 units to the right and 1 unit down, and then place your final result. If you're not, and you like writing things down a little bit more, here's what you can do. You pick some points on the parent function that are pretty kind of either easy to label, have easy coordinates. So let's label, what's the coordinate of this point here? -2, 0, and then this point here is, what is it? 0, 2, and then this point is 2, 0. Okay, so what you could do is apply the operations that this transformation is telling you one at a time. So this operation, what do I have to do to the x coordinates? I add 3, only to the x coordinates, right? So every x coordinate, I'm gonna add 3 to it. And so then that's gonna give me, what is that? -1 or +1? +1. The y value stays the same because I'm only adding it. This is only affecting the x coordinate. Yeah, right now I'm doing a step by step. Here, what becomes the new x coordinate? 3, 2, and then this becomes 5, 0. I'm not going to plot it because I'm not done yet. Now I'm going to do this operation, which is going to do what? Subtract 1, but now to the y coordinates. So only to the y coordinates, I'm going to subtract 1. So it's going to be 1, comma, what's 0 minus 1? -1. The x stays the same. 3 minus 1, sorry, 2 minus 1 is 1. And then this becomes which point? 5, -1. So now that you're done applying all the operations, now you plot these new points. That's where your final graph should end at. So now I You do it for both, because notice the first part, I did the horizontal transformation. But then the second part was the vertical transformation.
No, I know, but what horizontal shift transformations have both in vertical or they have vertical or they'll both have both?
What do you mean by both?
Like when you introduce vertical, you always shift it up or down.
And when you go, oh yeah, when you go horizontal, you either shift left or right. So there's two directions you can shift it to.
So when we get it, it will be all together, it'll have two shifts, a horizontal and a vertical.
It might not.
Okay.
It might not. Like, yeah, like the homework might just give you one. Or they might give you both of them. And then later on, after the break, we're gonna learn even more. Okay? Okay, so let me plot these final points. So so 1, -1. 1, -1 is where my final graph should end at. 3, 1. So 3, 1. And then 5, -1 is right there. Right? And so notice that this point moved 1, 2, 3 down 1. This point moved 1, 2, 3 down 1. And then this point moved 1, 2, 3 down 1. So then you just connect these 3 points so that it keeps the overall shape of the parent function. Okay. So like I said, you can either get visual and just move it yourself, or if you want to do more computational piece by piece, step by step, you could do it this way.
So also drawing the graph like that, that's not the final answer.
That's the final answer. This guy right here, the final answer is the graph of this transformation, which is this guy, this green one.
Okay.
Yeah. Now, if you do this on the exam or on a problem set, I think it's a transformation one. If you connect the points like this, then that's wrong. Because the transformation needs to keep the overall shape of the parent function. It's just the position where it's at, is that it moved. Rohan.
On the exams, would you want us to break it down how you get it the so what do you exactly what to just move it visually?
You can move it visually, but I'm probably going to have you describe what the transformations do so that I know that you know what they do. Yeah, those are hard to grade if I don't do that.
Would you say this is like a reflection, basically? Like the green one is reflecting the parent?
We're going to get to reflections, but that will happen. The
Okay.
graph does kind of shift.
Oh,
basically
okay.
Or
just
it's reflect, sorry.
shapes, like what we just showed to the or-
Yep. Yeah, so what this section actually covers is what you guys do on your phones when you go like this.
Oh, so like you're zooming.
You're zooming in and you're like either
I see.
stretching out the image or you're like moving it with 2 fingers, right? And you go like that. That's this. That's a transformation shift. You're moving it in different directions. Because notice that by applying an up and down and a sideways direction, I could have just moved it like that. But in reality, it's kind of doing this as well.
It's just like 3 points for the dot to dot kind of like not a function because we don't have one of those equations, right? Because like that one had the equation.
Yeah. So this is an example where you're given the function, the parent function, and you first have to graph the parent function, and then you do the transformation. Versus this one's easier because you're given the parent function already.
I think we're gonna have like both of these on this one.
Yes, yeah. Okay, one last practice problem for you guys, and then we'll take a break. Yeah, you're doing good. You're doing good. Let me. No, I'm gonna get rid of this. We'll leave that part. Okay. So, this is what I'm gonna want you to do. It's gonna take a while. So, graph, you already did it, but I'm gonna say it again, graph the parent function f of x equals this absolute value of x, just like you did last time. And then on the same coordinate plane, which is like this, like the XY axis, on the same coordinate plane, graph the transformations. Let me give you more than one. So I want you guys to graph, oh, there's only 2. graph g of x equals the absolute value of x plus 3. And then, once you do that one, then do a different transformation and do the absolute value of x minus 1 minus 2. Like that. Start with your parent function. You always need to start with the parent function. And then once you have that, shift it according to the transformations. So there should be 3 graphs on the same XY coordinate plane. Then in your answers, label which one's F, which one's G, and which one's H. Is this yours?
Yeah, sorry.
Okay. So remember, guys, it's the same parent function that you did last time, the absolute value one. It's gonna be. Make sure you label which one's F, which one's G, and which one's H. That's it. All right, take a quick glance of your classmates, see if you guys agree. See if you guys agree. Look. I don't know. Oh, almost. All right. Nice. So for those three.
Oh, the line.
I think it was an.
Oh.
There. Right. Okay. Maybe they can be class act.
Right. Let's do that.
Was it obvious? No.
It's sort of obvious, because then like I would be myself, right?
F should look like that. F should be that parent function. This guy shifts how? Left. To the left 3 units. So these points move 3 units to the left. This guy moves over here. And then these points move 3 units as well. So your graph should look something like that. This should be G. Uh-oh, I'm running out of colors. Let's see if this guy works. Oh, no. Crap. Let's try the red one. I guess I'm going with black. All right, this guy, how does it move? This one's
Right one,
Right.
right 1 unit
Down.
and down 2. Beautiful. So I get my parent function, not the green one, the parent function, F. And I'm gonna move it 1 unit to the right and then 2 units down. So it'll be positioned right here. So it'll look something like that. Okay. So that's 1 unit to the right and then 1, 2 units down. Perfect.
So
Question,
it's just a normal X, would you use parentheses for like the X movement?
say that one more time.
If it was a normal X, like not absolute value, would you just use parentheses?
Oh, yeah. Yeah, it would be labeled like that.
Yeah.
Good. Okay, let's take a break. It's been about an hour. Come back and then we're gonna do reflections and stretching it, okay? All right, come back at 1:58.
I think so, I think by the bathroom, whatever you want.
Downstairs, yeah, there's a water bottle
Downstairs has
filled. As long as it doesn't crack. Either. No, it doesn't crack. Something that looks like this, usually the screen is a little smaller. So that's a graphic. That's scientific. Do you have? Let me see your pen.
So what, that says graphic on it.
I think the safest bet is to look, yeah, is to go to the Mountain Engineering Center. And then just. Have another one. You ever screwed in?
I have a question. So it's not like on the, like, for example, I understand it, but the format. This doesn't mean that. When there's anything like.
That's recommended for. So I have mine, I see I 84 plus C.
Last night on GeoVex.
Yeah.
saying I was going to be on, we were breaking down the. Yeah. That's what I was telling you.
They can also manually override it.
Alright, I saw you this.
Do you want to know what Chad? That's what I'm saying. Like she can change.
Let's see. Oops, let me pause it. I did not want you guys to write all this out, so I was like, you know what, let me just make a handout. Okay. So kind of like what we were doing earlier, we're gonna look at this parent function, which is the square root function. And then we're going to either multiply 3 in front of the x squared, multiply it by 1/2, or put a negative in front. So let's start first by filling out the table for the square. So there's -2, you plug it in for x. What's -2 to the power of 2? Positive or negative? Positive, good. So we get 4, then you square the -1. 1, 0 squared, 0, 1 squared,
1, 2 squared, 4. All right. Okay. Now let's plot that before we do the other table. So let's plot it. So go to your table below here. And we're gonna do -2, comma, be careful with the increments here, okay? Here it's negative, they're going by ones, but here it's going by 5. So it's gonna be 1, 2, 3, 4. So it's -2 for x, but then 1, 2, 3, 4. That's this guy, and then we got -1, up, 1, and we got 0, 0, 1, 1, and then 1, 2, 4 up here. Yep, that's what
Isn't it gonna be farther out? The,
the y values.
the. Where's that, what is that? Oh, I'm doing
That-
it backwards.
That's a 2. Oh, yeah.
Starting at the top.
Gotcha. Yeah, start here in the origin. Be careful. We're YG, we're in this part of the
Okay.
handout, okay? And so that's a parabola. That's your parent function here, but because I kind of messed around with the labeling, the increments here, so that everything fits in one page, it's gonna be a little bit wide. So this is F. Okay, so now let's do G here, the table for G. When you plug in the -2, don't forget order of operations. What do I do first? Multiply or exponents? Exponents. -2 squared, 4 times 3, 12. Next one. -1 squared is 1 times 3 is 3. And then 3, 0 squared. It's 3 times 0, which is just 0. And then same thing, we're gonna get 3 times 1, which is 3. And then 3 times 4, which is 12. Notice those have really big y values. What's the relationship between the y values of G and the y values of F? You multiply them by 3. So notice that what we did is we multiplied y values by 3, a unit of a factor of 3. And that gave us these bigger ones. If I graph it, that's going to be -2, 12, all the way up. 5, 10, 11, 12. And same thing at +2. 5, 10, +12. Huh, it looks like a smiley face. It's cute. And then we got -1, +3. 1, 2, 3. +1, 3. Did the vertex of the parabola move, or is it still 0, 0? 0, 0. So notice that we're not shifting the parabola anymore. Okay. Now we ended up with this guy here. So what does it look like we did to F? We stretched it vertically. So it's like you grabbed it and you stretched it vertically upwards like that. Kind of like on your phone when you guys go like this vertically, it widens it up like that. Hopefully, if you're a color coding person, this will be nice. Questions so far? Am I going too fast? Okay, let's do H now. So H, I'm going to plug in -2. I got to do order of operation. -2 squared is 4 times 1/2 is 2. Next one. -1 squared is +1 times 1/2. 1/2, or in decimal, it's 0.5. 1/2 times 0, 0. And we get the same thing, 0.5 for positive 1 and 2 for positive 2. Now, what's the relationship between these y values and the parent function y values? Say it again. Dividing by 2, or you're halving it, right? Either way. So I'm going to say divided by 2. So we divided y values by 2. Okay. Now, a very important thing in this section is, so you guys understand, is that multiplying something by 1/2 is the same thing as dividing it by 2. Multiplying something by 1/3 is the same thing as dividing it by 3. Multiplying something by 1/c is the same thing as dividing it by c over 1, or just c. Okay, that's going to be important. Okay, let's plot this guy. We're at -2, +2. So I got to be careful here. -2 and then up 2. And then same thing with +2. So -2 up 2 units, +2 up 2 units. And then we got, be careful here, -1, but only up by 1/2. So that's halfway here. And halfway here. And we still have 0, 0. So now the parabola looks like this. Was it stretched? Did we stretch the graph of f? Kind of, but it's like it's called a compression. So it's like you compressed it. So instead of stretching it, you're compressing it. Vertically though, like up and down, like this. So now this gives us our function h. All right, last one. Plug in -2 here. Do I write it like this? Or like this? Bottom one, because that negative always has to be outside, like that, okay? So be careful here. I gotta think of this negative outside as multiplying it by like -1. -2 squared is 4, but then it gets negated to -4. Now I got -1 squared to give me positive or -1. This becomes a +1, and then you smack a negative in. And so then same thing, 0 times a negative is still 0, and then -1 and -4. -4, yeah, because you're squaring. Okay, so let's graph it. At -2, we are going to now go down 4 units. 1, 2, 3, 4. And same thing with +2. And then at -1, you go down 1 unit. Same thing with +1, and you're still at 0, 0. So now the parabola is going to face down.
The spider that ate a rainbow.
It does, huh? So what did we do? How does this, what's the relationship between these y values and the parent function y values?
By -1.
You multiply them by -1, or you can even do, however you want to say that, yeah, or reflected it. But let's just say multiply y values by -1. So notice that whatever operation you see happening is actually the same operation that you do to the y coordinates. I see a 3 multiplying, so I multiply that by 3. I see a half, so I divide the y values by 2. I see a negative in front, so I multiply the y values by -1. Okay. In function notation, for g of x, I'm sure that you guys can see this. Do you guys see how the x squared is right here? And it's being multiplied with 3? So we're gonna write this as 3 times f of x. Because, uh-huh, that's where you get to the notation, yeah. So here, let me, so you guys can see it. So this, think of it as you're multiplying 3 to the y values of f. So 3 times f of x. Because f of x is just the x squared. Versus here, h of x is going to be written as 1/2 times x squared. But what's x squared? F of x. And p of x is negative x squared. So it's going to be negative f of x. Because f of x equals x squared.
But that's the equation.
That's just for this parent function x squared, correct? But then you generalize that. So in the front of your packet is the generalization. For any parent function, it doesn't matter which parent function you have. If there's a negative multiplying f of x or a negative outside of it, you're going to reflect it across the x-axis. Oh, sorry, up and down across the x-axis. Okay. But what is it that you do to the y value of the original parent function? You're going to negate it, multiply by -1, so it turns into a negative y coordinate. If c instead is a number like the one we did, I think what was it, 3? Like this guy. If you're multiplying f of x by a value c, then it stretches it if c is greater than 1. But you just multiply c to that y value. If you have 1 over c, like we had 1/2, then ended up compressing it, and we multiplied y by 1 over c, or like I said, you're dividing it by c, the y coordinate. Okay, let's do an example with a random parent function, and let's see what happens. Okay, so I'm going to turn this off. Let's see what's gonna happen. The wings are about to get spicy. Yeah. You like that habanero? Here it comes. All right. So we're gonna do one that uses everything we've learned so far, okay? The shifting and these vertical shifts or vertical stretches. All right, let's see. So example. Given the graph of f, graph g of x equals -2 f of x plus 1 minus 3. Where here they give you the graph of the parent. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Okay, and your parent function is going to be that same upside down parabola we did last time, that you guys did for the previous problem. So this is f. Wait a little bit. While you're doing that, let me just label everything. 1, 2, 3, 6, 7. So it should be at the point -2, 0, 0, 2, and 2, 0. All right, I'm gonna go to the front of my packet and try to start identifying stuff. Here's where it's gonna get a little nasty, okay? All right, what does this bad boy do right here? That -3, the inside or outside?
Outside.
So does it affect the X's or the Y's?
Why is it go down 3?
So they're gonna go down 3. You're gonna go down 3, or what does it do to the Y coordinate? To the original Y coordinates, what are you gonna do to them? I'm going to subtract Y by 3. Okay. What does the X plus 1 inside do?
Last one.
Up and down or sideways? Which direction? Opposite, right? Left. So you're gonna go left 1 unit. Which coordinate does it affect? So what do we do? How does it affect it? You're going to subtract X by 1. Subtract X by 1 unit. So those are the shifts. That's what we did before the break. Now comes this guy here. See, here you're doing 2 things at the same time. That's where this gets nasty. Because on my sheet here, I have that if I have a negative outside of F, what does the negative do? Reflects it. But not only is it reflecting it, I'm having a 2 here. So it's being reflected and it's being stretched by by a factor of 2. Uh-huh.
Is that X or Y?
Is it inside or outside of the parentheses of the function? Outside. Anything that's inside of when you're inputting, anything that's inside the parentheses affects X. Anything that's outside will affect the Y.
Okay, so quick question, you're basically saying that -2F is going to be expanding it and down.
It's going to be stretching it and flipping it.
Okay, so basically, if it's behind the F in the parentheses, that's messing with the X. If it's outside the parentheses, it's messing with the Y.
Correct.
If it's in front of the F, it's now messing with the shape of it or positive of it.
You mean this, like in front of it?
In front of the F.
It's also affecting the Y coordinates, but in a different way than this one.
Yes, because it's not just now up or down. It's
Yeah.
like multiplier.
It's stretching,
Flip.
exactly. Yeah. Yeah, what you,
Doesn't the negative sign always affect like what shape it is, if it's gonna be facing up or if it's gonna be facing?
exactly, yeah, the negative does, I think you were asking earlier,
Yeah.
that's where the reflection stuff.
Okay.
Now, that's a lot to do, right? There's 4 things happening. So this is where this is where knowing how to manipulate the coordinates comes into play. It makes it a little bit easier, okay? Because we know this affects the Y coordinate.
Mhm.
How does it affect the Y coordinate? It just multiplies the Y coordinates by -2. So what I can write here is I can just say multiply Y by -2. Which, as you guys said, will make it reflect and stretch. But in terms of like figuring out where the graph goes, that will help me. Okay? So I can either do this visually, or I'm going to pick points like I did earlier, and then apply the transformations with the points. All right.
Yeah, do the multiplication first.
So now the order does matter. Because if I do the shifts, like let's say I move this down 3 units, right? That'll go from +2 to -1. But then if I multiply y by -2, what's -1 times -2? It'll put it back here. Versus if I multiply by -2 first, what's 2 times -2? And then bring it down 3 units, hella different. Okay,
So you're saying that we're gonna be plugging in a double x or something.
yeah, so what you're gonna do is like what we did last time, you're gonna see these points that are in the original parent function. I'm gonna write those points down as my guide, so -2, 0, this one was 0, 2. And then this one was 2, 0. And I'm going to apply the transformations, but when applying the transformations, always multiply or divide before you add or subtract, just like order of operations that you guys did with numbers. Otherwise, you're gonna get the wrong answer. So the order does matter. So I'm gonna look at my transformations and I'm gonna see, do I have to multiply or divide anything first? The y values, right? We said we're gonna multiply the y values by -2. So I'm gonna get all these y values. I'm gonna multiply them by -2. And then that's going to leave the x's alone. What's 0 times -2? 0 still. 2 times -2? -4, and then this stays 2, 0. I'm not gonna plot those points, but let's just see where they ended up. -2, 0 still here. 2, 0 still here. But the 0, -4 moved down here. So it's like the parabola is now stretched, it's longer, and it got reflected down below. Can you guys kind of see that?
Yeah.
Okay, so this bad boy went like that, but it stretched down so that it's connecting these 2 points like that.
And then does it like become like a full circle?
No. So you then you would ignore the blue part.
Oh, okay.
Yeah, it's like it's just. So it would, that's what this did. Notice that it reflected it the way you were saying, but it also made the parabola like longer. Okay. So it actually does do what we were saying it should do by multiplying the y's by -2. But I'm not done, so I'm not gonna graph it yet. Now I multiplied or divided. Anything else that I need to multiply or divide? No, right? Subtract and subtract. Now it doesn't matter which one you do first, because they're both subtraction. Pick.
You actually do them at the same time.
You could do it at the same time. Yeah. So to x, what are we gonna do? Subtract 1, subtract 1, subtract 1. And to the y values? Subtract 3, subtract 3, subtract 3. So then I'm gonna end with, help me out here, what's that gonna be? 0 minus 3 is -3. Here, what do we get? -1, -7, and then, careful here. 1 and -3. So now I have applied all the transformations. Those are the ones I'm going to plot now. So this point, -2, 0 moves to -3, -3, which is right here. Then we got 0, 2 moves to -1, all the way down here to 7. And then 1, -3. Be careful how you connect the dots. Does the parabola go like this? No, right, because they got reflected. So now your final result will be that. Parabola. Yeah. Reflected it, stretched it, and then it moved left 1 unit, and then it moved down 3 units. Boom, there it is. Cool. So on the homework, ooh, let me show you what's gonna happen. I'm saying ooh because WebAssign is gonna have you graph. And it's like, what the hell? How am I gonna graph on WebAssign? So let me show you. You're gonna wanna do all this work on your notebook so you can reference it. But then on WebAssign, I'm sure it works. Hold on. Crap. Uh-oh. Oh, I gotta turn this off.
I heard the internet was. I don't know if it's working.
Okay, so you guys see this problem here? Maybe not, it's too small. Oh, there we go. You see it? Okay. What's the parent function of this graph? X squared. Is the -8 inside the parentheses or outside? So what coordinate does it affect? How is it affected? Opposite. You add 8 units to X, so it's going to move it 8 units to the left. The +3 is outside, right? What is that going to do? Raise it 3 or add 3 to the Y coordinate. Okay, so the way that it'll start, it'll be blank. You have to first identify the parent function. In this case, it's the parabola. So I'm going to go to the parabola button. There's a sideways parabola and a vertical parabola. I want the vertical one. And the way you plot a parabola is you have to click 2 points somewhere. So I'm going to do the vertex, which is 0, 0. And on the parent function, give me another point on the parent function of just X squared. 1, 1, boom, and then I'll graph it. Okay. No, you're going to submit the final answer. So you guys told me I need to move 8 units to the right. So I'm going to move this 8 units to the right. See how it's doing that? It's going to be kind of annoying. This is why it's better if you do it on your notebook, on your sheet, and then plot the final answer. So on the final answer,
So they don't want it before and after, they just want.
no, they want the final answer. So this point is going to have to move 8 units to the right. Let me see. So right now X is 1, so it'll go to 9. And then how many units up? 3. 1, 2, 3. So then I got to do the same thing to this bad boy. 8, 1, 2, 3, like that. So that's my final answer. And then that's what you'll submit. Okay. Or you just clear it completely and you just say, okay, I do the work on my notebook, and then you just graph the green one. And then just find where those points are at and plot that. Okay. Okay. Good job. Okay. Let's go back to our packet. Nope, wrong one. Okay, now we're gonna do, uh-oh. Let me get the right one. Yeah. Double check that this is working. Okay. So now turn it over where it says horizontal stretching or compression. It says consider the following functions, fill in the missing X values. So we're not going to stretch the Y values, move them at all. We're gonna want the Y values to be the same. So let me give you guys some time before we just do it up here. Here, I'll do the first one with you guys.
So solving for X, Y.
Say it again.
What's solving for X, Y?
Right now, for this particular example we're doing.
It was like that for.
Yep, it was.
So is it normally always like that?
Normally it's gonna be like that, yeah. Yeah. Okay, so let's start with the 4 actually. So you want to figure out what X value do I plug in here? So that after I do all this computation, I get a positive 4. Okay, so go work yourself backwards. I know I'm square rooting something. So what needs to be inside the square root so that when I square root it, it gives me a 4? Square root of 16 or square root of 32? So go backwards. So I want a 4 as my final answer. So therefore, I'm going to have to square root the number 16, right? Then I got to work my way up. So then therefore, what X value do I plug in so that when I multiply it by a half, I get 16? 32. So then it'll be 32. This part, you won't do on the homework, okay? Yeah, you won't do that part. It's just the transformation stuff. Okay, so now let's do the next one. I want my final answer to be a 3. So what do I have to square root? A 9. This one's a little harder. So what do I plug in for X so that when I half it, I get a 9? When I half it, it'll be 18.
Oh, I messed up with that.
Yep. Because 18 times a half gives me a 9, which will give me a 3. So are you guys noticing a pattern between these X values of the parent function and these X values? What's the pattern that you're noticing? Doubling it, multiplying it by 2. That's what you meant, right? Yeah, so notice that what's happening is that you're multiplying, you're going to multiply X by 2, which is the opposite of what you see. Here it looks like it should be halving the X's, but no, you're going to be doubling the X's. So if I continue that pattern, what should be the next one here? 8. I just doubled this 4 to give me 8. Let's check. 8 times a half will be 4. Square root of 4, 2. And so then you just double the 1, and then when you double 0, it's just 0. So these are going to be confusing because what you see in the function here is actually going to do the opposite. Okay, it's going to do the opposite. Okay, let's do the next one here. So I want my final answer to be a 4. What number do I have to square root? 16. So therefore, what X value do I plug in so that when I double it, I get 16, which is 8. And then similar argument. I want a 3, so what do I have to square root? So what do I plug in? Oh, crap. What do I plug in? So when I double it, I get 9. 4.5, 4.5. So now what am I doing to the original X values? I'm dividing them by 2. Yeah, I'm halving them. So now what I end up doing is I divide X by 2. I see multiply in the function, but no, I do the opposite. I divide it by 2. Okay. So what should be the next one here? Divide that 4 by 2. Just 2. Divide that 1 by 1/2. Oh, sorry, divide it by half. No. Divided by 2. What's 1 divided by 2? 0.5. What's 0 divided by 2? 0. All right, let's do the last one. I want a 4. Therefore, I need to have a 16 under the square root. But my function has it so that there's a negative in front of it. And I can't square root negatives, don't forget. So if I plug in a negative 16, this negative and this negative will cancel to give me positive 16. So it should be negative 16. And then if I do the next one, I want a 3, so I have to square root of 9. So what do I plug in? I plug in a -9 so that the negatives cancel and I get what I want. And so what do you think the next ones will be? -4, -1, and then 0. So I'm just negating these x values. How would you guys want to say that? What are we doing to the x value? Multiply by -1, which would give you the negative, but because you see how here it looks like multiplying by -1, it's actually dividing it by -1 because it's doing the opposite, which is still going to give you a negative. So you're going to divide x by -1. Okay, let's plot these real quick. So I got 0, 0. Careful, now I have the x values like this: 1, 2, 3, 4, 5. 1, 1 is here. 4, 2 is up here. 9, 3 is up here. And did I get to 16? Oh, I do have 16. And then 16, here's 15. 16 all the way up to 4 is up here. So this is my parent function, f. A little dark. Now let's do g. G is, oh crap, am I going to fit that? Let's see, 0, 0. We still got that. 2, 1 is here now. 8, here's 5, 6, 7, 8, 2. And then I got 18, which is like all the way over here. 15, 16, 17, 18, 3. And I can't fit the other point. So I want you guys to think horizontally, sideways. If you graph the function f, the graph of f, am I squishing it horizontally or did I stretch it horizontally? What does it look like I did? So here's f. Did I squish f or did I stretch f? I stretched it. Okay. So notice that by me putting that 1/2 inside of the square root forced me to actually double the x values, which means it actually stretched it. So this forced you to stretch. All right, let's carefully do the next one. So I still got 0, 0, and then I have a half, which is right here, right halfway, 1. Oh crap, that's going to be very squished. Sorry about that. Then I have 2, 1, 2, 2. That's up here. And then we have 4.5. So here's 4. Halfway is 4.5, 3. And then we have 8, which is here's 10, 9, 8, 4. So this guy right here is h. So if I have f, did I compress it or did I stretch it to get h? We compressed it in this case. So this one gave us, we compress. And then the last one is pretty much the same graph of f. It's just that notice that the x values got negated. So I had -16, 4, which is over here. -9 right here, 3. And I had -4, 2. -1, 1. And then 0, 0. So notice that the graph, I've got my arm here is funky. that gave me P. So what did we do to the graph of F?
Reflected it water.
Across which axis? The y-axis, correct. So we reflected across y-axis.
You'd absolutely be on the outside of the square root, right?
If I did what?
If you reflected over the X.
Correct, yeah, because notice in the one we did in the back, I'm getting there, hold on, I'm almost done. Okay. Is the negative inside or outside the square root? Inside. So think of input, see how f of x is the square root function? So what you did here is you plugged in negative x inside of the parent function. So the negative is inside the parentheses versus the one we did before, the negative was outside the parentheses. Okay. 2x is inside the square root. So what did we plug in inside of f? You plug in 2x. Here the 2 is inside of the parentheses, which is why it affected the x coordinate in an opposite way. Versus here the 2 was outside of f, which is why it affected the y value. Oh, sorry, the 3 here. And then here you're plugging in 1/2 x inside of that square root to give you this function. So instead of dividing x by 2, you actually did the opposite and it multiplies it by 2. Okay. So moral of the story, if you do anything inside the parentheses, it's a horizontal transformation. It affects the x coordinates and it's going to do it in an opposite manner. Okay. No.
You don't ever have those,
Has what?
the access codes?
Oh, the bookstore?
They ran out.
They ran out already?
Yeah, I had to pay $111.
Let me go talk to them then.
Wait,
'cause
are you being so serious?
Yeah, because I went and they're like, there's no more.
You went today?
Yeah, I went last week. On Thursday.
No,
Okay.
You said they were supposed to get them today, right?
I put in an announcement that they were gonna order some more for this week.
Oh, really?
Yes, we can chat later.
Okay.
Yeah. Okay. Let me see real fast. All right. We're almost done. We're almost done. I know you guys, it's warm in here. Gotta turn this off. Oops. Section here. Okay, there's some more stuff, but I think this is the main one, right? So, important remark. Important remark. Be careful when you're given a horizontal transformation that isn't factored. Let me show you what I mean by that. Let's say the transformation looks something like this. Okay. So is the 6 inside or outside? Inside. So what do you think should happen? If I'm adding 6 inside,
Subtract.
it'll go left 6. But if you do that, it's wrong. Okay? Because what's really happening, so if you see something inside the parentheses that's not factored, If I factor it, it's gonna look like this. What can I factor out of here?
2.
Take out a 2 and I'm left with plus 3. That's the correct form that you needed in. Okay? Because what I'm really supposed to do is
Add it.
subtract 3 to x,
Oh, 'cause
not
that's-
6. It's the opposite, yeah. You gotta subtract 3 to x. Okay? If you guys look at the front of your sheet, you guys see the very bottom 2? Those are inside the parenthesis, right? So the very bottom one says f of cx. Do I multiply x by 2 or do I divide x by, sorry, do I multiply x by c or do you divide it by c? You're gonna do the opposite and you're gonna divide it, which is why you have 1 over c times x. If I have 1 over c times x inside the parenthesis, I actually do the opposite and I multiply x by c. So in this case, what is this 2 going to do to the x coordinates? See how see how it looks like I'm multiplying it by x, but I really do the opposite. I divide the x by 2. Okay,
Is it because of that opposite thing?
it's totally because of that stupid opposite thing. Yeah. So what really happens is that you're going to divide x by 2. And this is misleading you. What you really need to do is subtract x by 3, not 6. So be very careful. So because you're dividing, this will force it so that you're compressing. It's going to make the x value smaller. And then this will force you to shift left.
We will have a question like this. I won't be.
Maybe. Okay. So if you guys look at this page in your handout that says function transformation practice problems. I'm gonna do number 2 with you. And then I'm gonna have you guys try to do the other ones. Oh. All right, let's do that one together. Oh, what looks better, like that or like that? Oh, hell no. It's just, it's kind of blurry. It's cool. Hold on, let's see. I like, oh, I can. Oh, what the fuck? Okay, okay. So it says for the graph of the parent function f, sketch the graphs of the following transformations. So what's given to me is f already. That's f. Okay. So what you're going to need to do is you're going to have to determine what these transformations are doing. See how it's factored?
Yeah.
Okay. So let's start from outside. What is this plus 2 going to do?
It's gonna move left.
Is it vertical or horizontal?
That's-
Vertical, because it's outside the parentheses. How does it do it? What is it doing?
It's going up. That's it.
Up. So it's going up 2 or how is it affecting the y coordinates?
Slide.
You're gonna add 2, or I can also say add y by 2. That 1/2 right there is inside of the parentheses.
So we're
Dividing.
it's gonna be like.
It should be stretching because it's gonna do the opposite. Which coordinate is it does it affect? And do I divide x by 2 or do I multiply x by 2? I'm gonna multiply x by 2 because halving x, the opposite of halving x is doubling it. So I have to do the opposite. So I'm going to multiply x by 2. I have to do the opposite. And this x plus 1 in here is going to, you're going to subtract 1 to x, so it's going to shift it left. So you're going to subtract x by what? Okay, so now I can move it. If you're comfortable with that, go for it. I'm gonna go with the points just to show how you would do that. Now, which points do I pick? The terminal ones, right? The ones at the end. Let's maybe pick that one, this one, and maybe the corner ones. Yeah, let's pick some of those corners. Okay, let's see. My writing's gonna be a little small, which is kind of annoying. I apologize. So we got -10, 0. What's the one here? 0,
5 or 4.
4. It's one below it, yeah. 0, 4. Then I have 5, 6, comma, -2. And then the last one looks like it's 10, 2. Okay. All right, I'm gonna apply the transformations. Which one do I need to do first? Multiply or divide first. So I'm gonna just start with that and not even touch the minus or adding yet, okay? So which coordinate? X. So I'm gonna multiply all the x's by 2 times 2 times 2 times 2 times 2. So that's gonna give me -20, 0. 0 times 2, 0 still. 4. And then 6 times 2 is 12, -2, and then 20, 2. Oh, that 20 looks like crap. 20, 2. Can you guys kind of see that? Dang it, so small. Oh, wait, hello. There we go. 22. Okay. Now we're going to do the adding and subtracting ones. So the shifting. To x, we're going to subtract all the x's by 1. And to the y's, you're going to move them up. So you're going to add 2 to the y's. So let's see here. -20 minus 1. Careful. They're both negative, right? So you're gonna make them, combine them to give you -21.
2,
And then comma 2.
-1, 6,
-1, and then 4 plus 2 is 6.
11, 0,
11, and then the 2's cancel.
uh,
And then 19, 4. Okay, that's it. Those are my final points. So the -10, 0 moved to, ooh, barely made it. -21. I apologize for the squishiness of the work everywhere. -21, +2, right?
Yes.
So that's like right, barely made it. Right there. Let me zoom out now. Okay, then we got -1, 6, -1, 6. Do you see how this point moved over here and then this point moved right there?
Yeah.
Okay, so connect them. Because those points need to be connected. I don't have a straight edge or a ruler, but that should be straighter.
Are we also supposed to connect them as we follow up so we don't like?
Lose track, that might be helpful. Yeah, but if it's curved, connect it so that it's curved. If it's straight, connect it so that it's straight. Yeah. All right, and then we got 11, 0. 11, 0 is right there. So that connects with the second point. So then now that moves down here. And then finally we have 19, 4. 19, 4. Boom. So let's see. So this 1/2 really stretches the x values. The X value of this was 0, which is why it didn't move anywhere. But what ended up happening is that you stretched the X values. And then what did we do from there? We moved to the 1 unit to the left. And then we moved up 2 units. Okay? Let me have you guys try the other two. Try the other two problems. I'll leave this one here as a reference. Questions? Turn this light off. Oh, there you go. Damn, I should have done that to begin with. All right. Can I actually have you guys do this instead? Before you start graphing, just figure out what the transformations are for problems 1 and 3, and then just check with your group to see if you guys are actually getting the right transformation before you do anything. Okay? So just agree on the transformation for problems 1 and 3 with your group. Double check. Jenny, was that you? Do you need an eraser?
Oh, yeah.
Divided by 2. Reflected and we have to write out do we have to write out the coordinates?
Anyone else need any eraser?
Otherwise.
Oh, yeah. 'Cause it would
Negative
be-
X.
it would be-
Do we have to write out the coordinates each time?
Say it again?
Do we have to write out the coordinates each time or just?
No.
So you divide it, but. Oh, yeah.
Well, if it was X plus 1, it would be.
Yes, that
Right,
means
it's
that,
obviously-
Left, Y. So this one is like Y, yeah. Well, you reply.
Because when you already have those multiply by 2, negative, you have to-
So then, but it's not that. Before the, here. I would make these way. Yeah, we can divide by outside. So it doesn't play the opposite. But you're reflecting. Yeah.
Okay, because for the ancient X row, it went out that in front of your divide. I'm sorry. Yeah.
The top one's gonna be. The language side.
You subtract by 5, you multiply it. Why? Here, the existing document is 2 Inside,
So I don't know.
inside you would divide.
Wait,
It is confusing now, so what?
So then the one.
So this C, and then the number outside.
You're always dividing that.
That's the C inside.
Yes.
So all of that, you have to divide it next one. So, yeah, I mean, you're gonna, you know, what we're going to do this.
That's what it was.
So that's two.
Yeah.
Yeah.
Just know what, it's like, that's how it works.
Oh,
I can remember when that. I don't know, kind of click on that. So,
right, by one.
I'm losing the.
Well, so you right, you do right by one, and I got one X, right? Then you gotta do opposite.
It's back to the correct on the wire.
You know what?
Yeah, I think,
It's the same.
I think it just needs.
I have the. Oh, shoot. Yeah. Let me get this real quick. Oh, that's showing you guys. Okay. All right, I'm gonna post the solutions to this one that you guys are working on. Give me 1 second. It's gonna be on the week 3. Function, transformations, practice. Solutions. Okay, you guys go to the week 3 videos and handouts, the solutions are there, okay? You want to reference it?
And then you're going to the last. Yeah. What's it about? Negative. So like. Negative sign. Yeah. And the light is down. There's only 2 things. Yeah. So. Keep going, guys. Is this?
Okay, real quick, just so that we can get past this step here. So there's a 2 for number 3 outside the parentheses outside of F, and here there's a 2 inside. Okay, so if you guys look at the handout, the very bottom, it says y equals f of cx. Is that the case? Is that something like number 1 or something like number 3? Is that thing inside the parentheses? Inside, so it'd be like this one, right? And what does it say to do to the coordinates there? Yeah, we're gonna divide the x by that c value, right? So in this case, in this 2, you're gonna do the opposite. It looks like you multiply, but it's always the opposite with x. So you're gonna divide x by 2. So it's really gonna compress it. Versus the 1/2 is outside of the parentheses. So which coordinate is that?
Why?
It's y. If it's outside, it's y coordinate. Does it do it the opposite way? It does not do it with y's, you never do the opposite. Okay? With y's, you never do the opposite. So it looks like I'm multiplying y by -1/2. Because it's literally the way you see it there, okay? So you're going to multiply y by -1/2. Or divide y by -2. However you want to say it. Or you can say divide y by -2. Either one of those will give you the same thing. Is that okay?
Yeah.
All right. What about for number 3, this 2 here? What is it affecting x or y?
X.
Is it inside the parentheses of f? Are you inputting it?
No.
Actually, I should say that. Are you inputting it or are you not?
It's, you're out. It's an output.
You only input when it's inside the parentheses. So it's not being inputted, so it's going to affect the y coordinates. Therefore, it's not opposite. So you're going to multiply y by 2. -5. Is it being inputted or is it not being inputted? It's not inside the parentheses, right? So which coordinate? Opposite?
No,
No.
so it's going down.
It's going down. You subtract y by 5, so it goes down. And because this one's multiplying y by 2, it's going to stretch. Okay, what is this random negative going to do? Which
It's
coordinate?
gonna, it's a y-axis. No, wait, the x-axis, because it's in the parentheses. Oh, you should just-
Let me answer, let me give you 2 questions. One is, which coordinate does it affect? X or Y?
X,
X, which is gonna force you to reflect
Right.
across which axis?
or the y-axis.
The Y axis.
Okay.
So you're going to, in this case, divide, because it's opposite, X by -1, which is gonna make it a negative value, right? It's gonna negate it. So you're going to reflect across the, what did we say? Reflect across,
The
yeah,
y-axis.
the Y axis.
Sorry.
Because you're dividing the x. So if it's positive, it turns negative. And if it's negative, it turns positive.
Shouldn't it reflect across the x-axis?
Because you're starting from the x. It's in the parentheses. So
Because in the parentheses, so it
Yeah.
reflect across.
So
Well, inside the parentheses means that it affects the x coordinate, which is what it's gonna do.
Oh,
and then you.
I was
flip it.
doing the right thing mentally, but not wording it correctly.
Okay, yeah, that's why I was like, let's separate those 2 questions.
Yeah.
Yeah, because those are different. Okay, and then the last thing is this bad boy is going to subtract
One,
which coordinate?
X,
Let's subtract x by, so which direction is that?
so
You're gonna go to the left. Okay, yeah, bro.
So you have the final coordinates.
I should have it in the solutions. In the solutions. I'll go check it, Okay, when I start doing my transformations, what do I start doing?
Multiplying and
This outside?
the
The multiplying outside. So I can start with this guy and
middle one.
as long as you do divide, multiply and divide first, do those first.
Put those together.
So let's see, so
Multiply y minus two divide a one. So do we just negative?
let's see, hold on. So let's use the same points we did before. So it was negative 10, 0, 0, 4, 6, negative 2, 10, 2. Okay, I'm gonna do the multiplication division first. So this guy's gonna multiply the y coordinate by 2. All the y coordinates get doubled. Please be recording. Oh, thank God. Okay.
Oh, and then x
And then
is going
to be divided.
By -1. Yeah, see, it says divide x by -1. So then all the x values, I'm gonna divide them by -1.
And then when you get your results of that, you just.
So now, help me here, that's what, positive 10?
Yes.
What's 0 divided by, oh, sorry, 0 times 2? 0 still. 0 divided by anything will be, well, 0 divided by anything that's not 0
Negative.
will be 0.
Yeah.
4 times 2 is 8. And then divide that by -1 gives you -6. -4. -10 and then 4. Okay. So I did my stretching, compression, reflection, I took care of all that.
Why you're gonna multiply, I mean subtract
Subtract
X by 1.
by 1 and then
Y by 5.
y by 5.
So 9,
Yeah, so then you're gonna get 9. I'm subtracting here, right? Yeah.
Yeah.
It's 5. -1, 3. 3.
1 by 5. Or is this gonna?
Which one?
Oh, that.
This one? It'll be
negative.
-7, -9. And then here, -11, -1. So those will be the final points that you plot.
So that 4 that you originally wrote in the second one, it's actually a 9. No, so 0, 4, that's actually a 9.
Crap. Wait. It's, I think, this point on top. So it should be 0,4.
Alright.
Cool? Okay. So plot these 4 points, and then that should be your final result. Okay, so you're gonna use this handout during your homework. I think your problem set this week is only on transformations, okay? And then the last thing I wanted to say was, I'm not gonna test you guys on this, but you might see some of this show up. On the page called Determining Odd and Even Functions. It's a short description of what they are. And it's basically uses transformation of symmetry,
Okay.
okay? And then it just gives you examples and stuff.
Okay.
So take a look at that. All right, I think we're done. Woo! Good job, guys. We did transformations in 1 day. That's crazy. Holy crap. You guys should applaud yourself. This is usually a two-day section.